Thank you very much, everyone. This is Eric Zwiefel. So we definitely are excited to talk to you about Azure Machine Learning and Microsoft R Server today. But before we get into the technology talk, we want to spend a little bit talking about Microsoft's team data science process. Our team data science process is an open source, agile, iterative process that's really based on, if you're familiar with CrispDM. So it takes a lot from CrispDM, but it's really meant to be for cross-functional teams as you're answering data science questions. So it starts off with a business understanding and get a true understanding of the questions being asked, document all of that, then go into data acquisition and understanding, onto modeling, and to deployment. But one thing you'll see here is that this isn't a traditional life cycle where each step goes to the next. This is really a network of steps, if you will. Because as you know, once you get to building a model, you may know, hey, I need a little bit more data, so you go back to that data acquisition. Or you deploy the model and you say, we need to update this and continue making iterations on that. So really, this is a recognition that that occurs, and then also talking about how to work through that as a cross-functional team. Now, I call this out specifically before we start because a lot of what we've been building into the Azure Machine Learning and Microsoft R Server borrow heavily from this data science process, and are really meant to unlock the potential of this. This isn't to say you can't use those tools if you're not committed to TDSP, but it's just they're a little bit better together, if you will. Now, there's two links here, aka.ms TDSP and TDSP-utilities. TDSP is the GitHub page where we publish all of the guidelines that we have, suggestions and so on, really talk about the team data science process. And we want this to be a community endeavor, so if you have suggestions on refining this process, please let us know. The second one, the TDSP utilities, is a set of artifacts and utilities that really help unlock this. So the artifacts may include templates for report outs to your stakeholders. Utilities might include Python and R scripts that help you automate data understanding and things like that. So definitely two great resources for you to check out. So now that we've talked about the team data science process, let me talk a bit about Azure Machine Learning. So Azure Machine Learning is our software as a service offering as to enable machine learning projects. It has a drag and drop interface that allows you to build and deploy models. Really, this is meant to lower the barrier to entrance for data science, and you can have both hardcore data scientists that get a lot of benefit from this platform, but also maybe there's those new to that, or new to data science, or maybe analysts that just want to start building out predictive models. They'll get a lot of benefit as well. Now, it's built to allow you to bring in the data, do the data munging, go on from training your models, scoring them, and evaluating them, and so on. And there's a standard set of models that are out there around classification, recommendation, clustering, regression, and all of that. Plus, on top of that, you can execute R, Python, and SQL right from within Azure Machine Learning to allow you to, again, do some of that data munging, train models. You can even import libraries from the open source community into your Azure Machine Learning environment to be able to use those. Now, there's another link here, aka.ms AML cheat sheet. This is an 11 by 17 poster that shows you all of the different models that are in Azure Machine Learning, as well as what types of problems that those models are typically good for, whether it's a clustering, regression, things like that. Now, I mentioned that you are able to build and deploy models. I'll show you a bit later that by deploy models, what I mean is with 3 clicks, you can take a trained model and publish it as a RESTful endpoint. So then you can consume that models just via a REST API from there forward. Now, as I mentioned, the Azure ML really complements TDSP, that team data science process. And it's a very iterative approach. As many of you know, when you're working on a data science, it's not just, I can define the project and go build it. It's, I run an experiment, I see what kind of prediction I'm getting, I realize I need more data, or I need to do some feature transformations, feature engineering, and so on. So it's really meant for that iterative process to keep making your model better, including after you deploy it, to allow you to make that better, and so on. Now let's show you those 3 clicks to deploy a RESTful API endpoint. So you see here we have a model that has run. If you get into play with Azure ML, you'll get very used to this interface. But I guess the way you can tell that my model has run is there's the green check marks next to each of those stages to say, yes, this has run. So then I click Set up a web service. After that's done, my screen changes to show me 2 different boxes that were added, a web input and a web output. So this will then show you where you're going to get the data in and where you're going to push it out. It allows you then at this point, if you want, to start changing the steps in between. If you need to inject new data into your web service output, that's a possibility here. So different things you can do after that. Once you have that ready, you're ready to go. The next click is Run. That runs your model that you've developed, again, with the new web input and web outputs, again, just to make sure if you've made any changes that these all work together. And then after that, you click on Deploy Web Service. Now, once you deploy the web service, it brings you to a management studio for your RESTful API endpoint. Now, this RESTful API endpoint includes the Swagger documentation. So for those of you who are familiar with REST and Swagger, you can then take that and use it elsewhere as you're leveraging that API. And again, we allow you to take that same API endpoint and change the model underneath and make it better. So as you are improving your model over time, you don't need to make any changes to your code for the consumption of that model. Now, there are a lot more steps, a lot more to this environment than I'm able to do justice in 45 minutes. We could spend an entire 3-hour, 4-hour session just talking about Azure Machine Learning. So I really encourage you to go out and check it out. You can get to it at studio.azureml.com and go check it out and see what you think. There's also many training resources that you can leverage to get more into that. So that's Azure Machine Learning. Now I will kick it over to Scott Donahue, who will talk to you about Microsoft R Server.
Thanks, Eric. Hi, everyone. This is Scott Donahue. To complement the UI-based approach to machine learning that Eric talked about, I'm going to give an overview of our coding-based platform, Microsoft R Server. So I imagine much of this audience may already be familiar with R, but I'm going to give a quick overview so that I can contrast the features of open source R and Microsoft R. R is an open source language developed in the 90s specifically for data analysis. It has a huge and growing community of users that contribute to and extend the language by creating add-on packages that add new statistical and machine learning functionality not included in the base language. And most of these packages are collected in an online repository called CRAN for Comprehensive Archive Network for any R user to install and use. Now, despite its popularity, open source R does have some limitations, so we're going to go over those and how Microsoft R deals with them. First, open source R does not scale to handle big data sets well. All data that R operates on must be able to fit in memory. For performance, the second limitation is performance. Open source R was developed before the wide availability of multi-core CPUs and large compute clusters. The base language in most open source R packages are not able to take advantage of those compute resources. Third, operationalization. Open source R does not include easy ways to deploy models into production. And last, support. Open source R has an excellent community of users to help with problems on open forums, but this is usually inadequate for large enterprises that do need official support for production workloads. So let's look at some of the features of our server and how it addresses these. For scale, we scale from workstations up to large clusters. We can scale on data that is on disk so that we're not limited to in-memory data sets. For performance, all Microsoft R algorithms are multi-threaded and distributable, so we can run them in parallel and take advantage of multiple cores. And for operationalization, we have a write once deploy mini model in which you can develop your R code for a test platform and a test set of data, and then deploy those R assets and models to a large compute cluster or a SQL server where they can be operationalized in the form of stored procedures or web services. And for support, Microsoft offers 24/7 enterprise support for our server. So I want to take a high-level look at the investment principles and the philosophies for Microsoft and R. It's built on top of open source R, so we have access to all of the 10,000 plus and growing CRAN libraries, and we're completely compatible with that. We offer enterprise-grade operationalization and support for production workloads. Open source R offers many packages for accessing different data sources and running in different platforms. Microsoft R brings all of these into a single package, so we have native support for all of these data sources and compute environments. And as I said, we're built on top of open source R. The only change we make to it is we build with the Intel math kernel libraries, which enables multi-threaded capability for mathematical operations, and in fact does speed up some open source R package operation. But it is fully compatible with all existing R packages. And lastly, time to value. Microsoft has a gallery of pre-built solution templates for solving a lot of common types of problems with our server, including market campaign optimization, predictive maintenance, credit risk analysis, and things like that. So a high-level view of the platform itself. At the top, we have all of the tools that are supported. All the tools that work with open source R also work with Microsoft R Server. In addition to all the CRAN R packages supported, we had 2 new packages. These are proprietary, called RevoScale R and Microsoft ML. And what these are is they include scalable, parallel, distributable implementations of common statistical and machine learning algorithms. In our server 9.1, we have native support for all the data sources listed here and support for all the listed platforms. Our server allows you to express data sources, compute platforms and analytic code independently, so you can develop code for one data source and platform, then change either or both of those without changing the analytic code itself to support a write once, run anywhere. And on the right, we have our operationalization options in our server, which I'll cover later in the presentation. So one of the two proprietary enhanced packages we have in our server is called RevoScaleR. And these, like I said, these are reimplementations of commonly used statistical algorithms and machine learning algorithms, but implemented to take advantage of a parallelization platform in our server called Pima. So that all of these functions can run multi-threaded on a single workstation, multi-core on a single workstation, or across nodes in a compute cluster like MapReduce or Spark. The second package that we've added to our server is called Microsoft ML. And what this is a supplementary package that we've added fairly recently of algorithms that have been developed internally in Microsoft for Bing, Office, Xbox, Skype, and other internal groups. And what they've done is taken these algorithms that have been battle tested and are very, very high performing and put them into Microsoft ML package in Microsoft R. So if you're familiar with XGBoost in our server, we've got a boosted tree algorithm called FastTree that actually outperforms XGBoost. So this diagram gives an overall picture of the architectural possibilities with our server. On the right are all of the supported platforms in which our server can run, either in cloud or on-premise. And on the left, we've got an R client. This is a free distribution of R from Microsoft that includes scaled down versions of the Microsoft ML package and the RevoScaleR package, but you have access to all of the functions in those packages. You're just limited to 2 cores and working with data in memory. But what it allows you to do is to do your development and analysis on small data and your experimentation on the data scientist's workstation. And then when they're ready to test on larger data, they can push that code directly into one of the platforms and environments on the right, directly from the client. So I want to talk about one of those platforms on the right from the previous slide, because it's a little bit different from our server behavior and all of the other platforms, and that's our SQL Server, our services. So in SQL Server 2016, we introduced our services. And what this is we embedded it in the SQL Server instance. We embedded our server in the SQL Server instance so that you can actually execute our server code, our code in database in SQL Server. So we're doing away with the need to move data around, and we see a 10 to 50 times performance improvement when code is run in database in SQL Server. Not only can we run our code in database from a remote R client, but you can call our code directly from T-SQL. So the T-SQL programmer can leverage the R capabilities in database as well. What's more, when you have a model built, you can publish that model, that R model, in SQL Server as a real-time scoring, stored procedure. So one thing to call out here is down at the bottom. This mentions Python support. If you go out and look for the SQL 2017 preview, we are including just what we have with SQL R services, but we also give you the ability to run Python in database with SQL Server. Just like our services, we've got a RevoScale Pi with scalable, distributable Python functions and Microsoft ML access. Okay, so I want to talk a little bit about our operationalization. So we have two ways to put our code into production with our server. One is what I previously mentioned with SQL Server, is that we can publish our code as a T-SQL stored procedure that can be called from other SQL or applications. But we also have the ability to publish in a single line of code an R function as a RESTful web service. So once that's done, you can score your new data by calling this RESTful web service. We can score data in real time. It's highly available and scalable through the use of multiple R server backend compute nodes and multiple front-end web nodes. As well, you can take that web service and publish Swagger JSON definition directly from your R code so that application developers can consume it to build clients. So here's a look at the architecture for the Microsoft R Server web service-based operationalization. The data scientist on the left would write their code and write a function encapsulating their R code or their model, and use the publish service command to create the web service front end for that function. And once that's published, another data scientist from a different R client can call get service to get all the definitions for that service that they need in order to call it from R. Or an application developer can also call get service to get the service definition or the Swagger to build a REST client to call it. So that's about all the content I have today. What I have here are some getting started resources. I would encourage you to go out and look at Azure Machine Learning and all the resources here for Microsoft R Server. In particular, the Azure Data Science VM is a pre-configured VM in Azure with development evaluation editions of both R Server and SQL Server R services, and a lot of related R tools. Additionally, down at the bottom, you can click on the SQL Server 2017 preview and download that to install and look at the new functions that are available for Python in SQL Server 2017. Thank you very much. That's all we have. Are there any questions?
So this is Eric, if I can jump in here. So I would say, first off, our Microsoft Ignite conference this week. There are a lot of things that I would love to tell you about that will be announced next week. So if you go online, search for Microsoft Ignite, you can tune into those webcasts to see the new announcements there. That there's a lot of really cool things around the data and AI space. So that would be definitely some things to check out there. And additionally, like Scott said, we have so many things. There's so many resources here just around R Server and Azure Machine Learning. There's also many other things in the Microsoft ecosystem that I would encourage you to check out, including some of the things that we're doing around field programmable gate arrays, FPGAs, if you're familiar with those, to enable AI training and deployment on FPGAs. So I would research that. also some things around the stance and what we have around Docker containers and deploying trained neural network models to a Kubernetes cluster using Docker containers. There's a lot of different blog posts out there around how we can enable that for you. Now, we do have a few questions that are coming in. So the first question is, so if I know R, can I leverage that using Azure Machine Learning? So yeah, great question. As we mentioned, with Azure Machine Learning, you can both use R scripts to do data transformation, data munging, and so on, pulling in external libraries as needed. In fact, I worked with one customer who had written his own library in C and was calling that an R. And we were able to bring in that C script and leverage that as well in Azure Machine Learning. And additionally, you can also use common R libraries for models, build and train models using R script, and then deploy those with Azure Machine Learning. So Scott, I don't know, maybe you answered this. One of the questions we have here is, what Hadoop platforms are supported for Microsoft R Server?
R Server is supported in HDN side. In HDN side, it's pre-installed and configured, so you can actually create an R Server Hadoop cluster in Azure. For on-premise and IaaS Cloud, we also support Hortonworks HDP, Cloudera, and MedBar.
Okay, great. And are there limitations on the underlying Linux distribution that the Hadoop platform is distributed on?
We're supported on Red Hat, SUSE, and Ubuntu for standalone R servers.
Great. Let's see, the next question is, how is R Server installed with SQL Server?
Yes, for SQL Server R services, it's not a separate installation and integration. Rather, it's actually a feature to select in SQL Server 2016 and now 2017. So when you run the SQL Server 2016 instance installer, you will see two options to check. One is the embedded R services component that allows you to do in-database analytics and run R directly from T-SQL, and also a standalone R instance so that you can install R just on a Windows workstation.
Okay, got it. Let's see, next questions we have. So we have a question, if I don't know coding, R, Python, Julia, but I want to train models, is Azure Machine Learning a good fit? So yeah, I would say definitely Azure Machine Learning is something that you should check out then. There are a few things that I would recommend before you go into that. The first would be, if you search for the Cortana Intelligence Gallery, there's a great set of resources there on pre-trained models, reference architectures, and so on. So you can see how others have approached these problems and then leverage that for yourself. Definitely a great resource as you're getting into it. Some of the key things that I would recommend, just off the top of my head, if you're not familiar with data science, as you're building models, one of the most important things you can do is split your data. So there is a split data module, and you want to split your data in test and train data sets. This allows you to monitor and avoid overfitting. Overfitting is where your model just starts to explain random noise in the data instead of explaining the underlying, if you will, the underlying world behind it. So that would be kind of the number one thing I would recommend as you start building your own models there. So yeah, great questions there, and definitely a place to look into. So what other questions do the audience have? Yeah, go ahead. Is it Joe?
That is Joe. I think what you were onto there is a great question, which is sort of, what are the resources people can use to just get started, and then what are the ways that people can get like free data sets or something to be able to go ahead and test their skills?
Yeah, great question. So with Azure Machine Learning, there is a set of data sets that are pre-built in. That one of the drop-downs is just a data set. You see things like the UCI bike rental example. That is a pre-published data set that's there. The Titanic data set, Iris data set, and so on. If you're not familiar with those, as you start to dig in more and more into machine learning and data science, these are going to be recurring data sets that you see all the time. So that would be a great place to get started there. Additionally, Microsoft partners very closely with edX. If you're not familiar with edX, it's edX.org. It was started by Harvard and MIT as an online platform for courses. So Microsoft maintains and publishes many different classes out there in this space specifically, including classes specifically on how to leverage Azure Machine Learning, classes on how to leverage Microsoft R Server. There's even classes that Microsoft has out there that are the Introduction to R and Introduction to Python type classes. Plus, at that resource, there are many, many different colleges and organizations across the planet that are also contributing and publishing classes there.